Assalamu alaikum warahmatullahi wabarakatuh. Now, students, we are going to start another unit which is related to the energy with chemicals. There are two types of chemical reaction energy wise. One is called endothermic and the exothermic. Whenever a chemical reaction take place, there should be a energy change. This energy change could be in the form of release of energy or in the form of absorbing of the energy by the reactants. In this unit, we will discuss the difference of these two types of reaction, exothermic and endothermic, and uh, what are the factors which can change the enthalpy change of a reaction. So, now we will start this unit.
Assalamu alaikum, student. This is your chemistry teacher, Rizwan Khan. Our today's topic is energetics, or it is also known as energy from chemicals. In this topic, we will discuss two types of chemical reaction. Energy-wise, we can classify chemical reaction in two types. One is called exothermic, the other one is endothermic. We classify chemical reaction energy-wise in two types, exothermic and endothermic reaction. In exothermic reaction, chemical reactions involves the breaking and the making of bond. There are two types. There are two processes in a chemical reaction. The bonds of reactants are broken and new bonds are formed to form products. So energy is always needed to break down a bond. Whenever the bond of reactants are broken, we need an amount of energy. And when the bonds are formed, the energy is released. So bond breaking is needed energy, and bond formation releases energy. So if more energy is released than is absorbed, the reaction will be exothermic. And if more energy is needed to break the bond than is given when new bonds are formed, the reaction will be endothermic. In short, if we need energy for a chemical reaction, it will be endothermic. If the energy is released by the reactor or by the process, it will be exothermic reaction. Now, energy profile diagram, or it is called energy level diagram. We can draw energy level diagram for both of the reactions, exothermic and endothermic. In an exothermic reaction, the reactants are always at high energy level. When they release energy, the product form at lower energy level, see like this. Now we can see that the reactants are at high energy level and products at the lower energy level. The energy difference between the reactants and the highest energy level is called activation energy, and the difference between reactant and product is called enthalpy change or delta H. This is the energy which is given out by the reaction. It is called enthalpy change, and it is denoted by delta H. Okay, so there are two terms: energy of activation or activation energy and the enthalpy change. To define activation energy, it is the amount of energy which is required to start a chemical reaction. Okay, it is the amount of energy which is required to start a chemical reaction. So each and every reaction needs some amount of energy to start. Otherwise, the reaction does not start. When we provide this activation energy, then the reaction started. The activation energy for an exothermic reaction is small, while for an endothermic reaction we need a high amount of activation energy to start. Okay. Second thing is energy given out by the reaction, or it is called delta H. Delta H is the energy difference between reactant and product. It is actually the energy difference before the reaction and after the reaction. If we use a catalyst reduces the energy of activation. What we use catalyst, why? Because to increase the speed of a chemical reaction. Catalyst speed up a chemical reaction without use of itself. So when we use catalyst, what it does, it reduces the energy of activation and the reaction will be faster. But when we use catalyst, there is no difference in delta H or enthalpy change. Enthalpy change remains constant without catalyst and after the catalyst. Catalyst only affect the energy of activation. Okay. So whenever we use catalyst, the energy of activation of any reaction will be lower and the reaction will be faster, but there is no change in activation in enthalpy change. Now, what is enthalpy? The energy contained in a chemical bond that can be converted into heat is known as enthalpy. Enthalpy is given by the symbol H. Enthalpy cannot be measured directly. There is no theoretical method to calculate enthalpy. We have to perform the experiment and then we can measure the enthalpy change. So enthalpy cannot be measured directly, but enthalpy change can be measured because this is a difference before and after. Okay, but it should be experimented. Now, for an endothermic reaction, delta H is always positive because system or reactants they absorb heat energy. When they absorb heat energy, the delta H will be positive. Okay, but for an endothermic reaction, the delta H always negative because heat is given out to the surrounding from the system. The system loses energy. That's why the sign of delta H for an endothermic reaction is always negative. This is the energy profile diagram for an exothermic reaction. We can see here that reactants are at higher energy level, but the product at lower energy level. So when the reactant release energy, product is formed. That's why delta H is negative. So for an exothermic reaction, more energy is given out than is taken in. The examples of exothermic reaction, all combustion reactions are exothermic. Respiration is exothermic. Bond formation is exothermic. Okay. So these are few examples of exothermic reaction: combustion, respiration, and bond formation. For an endothermic reaction, the reactants are at lower energy level and products are at higher energy level because the energy is absorbed during the process. Reactants absorb energy and the product will be at high energy level. So in this reaction, delta H should be positive. The sign of delta H will be positive. Endothermic reaction is taken in but not necessarily given out. Energy is taken in but not necessarily given out. It means that an endothermic reaction always needs energy. It does not release energy. It always absorbs energy. Okay. One of the example of endothermic reaction is photosynthesis. In photosynthesis, we know that plants plants produce their food, and for this process they need sunlight. Without sunlight, photosynthesis does not occur. So sunlight is the source of energy for photosynthesis. That's why photosynthesis is a endothermic reaction. The other examples of endothermic reaction are all decomposition reactions, electrolysis, also endothermic reaction, bond breaking. Bond breaking is endothermic, always. Okay, so these are few examples of endothermic reaction: decomposition, electrolysis, photosynthesis, and bond breaking. If a reaction is reversed, for example, a reaction is exothermic in forward direction, it means that it will be endothermic in reverse direction. So the sign of delta H will be reversed. If a reaction is exothermic in forward direction, it will be endothermic in a reverse direction. And if a reaction is endothermic in forward direction, it will be exo in reverse direction. So sign of delta H always reversed. That's why in a cyclic process, the delta H always zero. These are two delta H are given, and plus 90.83 and minus 90.83. These minus and positive sign only shows the direction of heat, but the magnitude is same. Different sign, same magnitude. So the sign only used to represent the direction of heat, endothermic or exothermic. Otherwise, the magnitude is always same. Delta H is used to measure the uh, it is used to measure the energy change. Either the reaction is endothermic or exothermic. Negative values always indicate endothermic exothermic reaction. Positive values indicate endothermic reaction. And changes in sign when a process is reversed. Therefore, a cyclic process has the value of delta H zero. Okay. So far we have discussed the exothermic reaction and endothermic reaction, their examples, and the energy profile diagram. I hope that you will understand this topic. Inshallah, in the next video, we will discuss the other factors of endothermic and exothermic reaction. Inshallah. Goodbye.
Okay, students, now we have completed our unit which is called energetics or energy from chemicals. We have discussed in this unit all the topics which are related to your syllabus. Now I hope that you are able to solve your past paper and other questions which are related to this unit, inshallah.